and this chapter is about the graph coloring. So graph coloring means actually you have to color a graph or the color the vertices of the graphs in a way that no two adjacent graph actually get the same color. So this is the concept. So that means mute again, someone want to join. Suppose if we take just this as a graph, I have already discussed this. So suppose this is a graph. This is a simple graph suppose, and where the vertices are suppose A, B, C, and D. And now we want to actually give the color to the vertices of the graph in a way that no two adjacent vertices will get the same color. So this is the concept. So that means suppose if you start with coloring this vertex A, suppose if you give red to the vertex A. So after that this adjacent vertices is B, so you can't give the B with the same color. So we choose the green color suppose at the point B. So after that you can see that D and C both adjacent to B but not adjacent to A. So that's why you can again fill the C and D vertices with the red but not the D, because this D vertices again adjacent to which? Red vertices. So now you can see D is adjacent to B, also D is adjacent to C. So that's why you have to choose another color to fill that vertex, and again suppose we take one blue color to actually fill the vertex. So this is the concept. So that means you have to color each of the vertices in a way that no two adjacent vertices will get the same color. So here if you see these vertices, you can see that no two adjacent vertices have the same color. So now here actually you can color the graph by using 1, 2 and 3 colors. You can also give some different color in this C. That means instead of this color you can also take here a yellow color. It will also produce a coloring of the graph, and where no two adjacent side have the actually vertices have the same color. Is it correct? Or you can, that means 1, 2, 3 and 4, by using 4 color you can also color the graph. So from here we have the term that means a k vertex colorable. What is k vertex colorable? Vertex colorable concept. So k vertex colorable means a simple graph G. Suppose G is a simple graph, so a simple graph G is said to be k vertex colorable if it is possible to assign, if it is possible to assign one color, to assign one color from where? From a set of k color, from a set of k color. So suppose here the set of k color is the red, green, this yellow color and the blue color. This is the set of k color to each vertex, and such that no two adjacent vertices, no two adjacent vertices, suppose this is vertices actually are assigned with the same color, assigned with the same color. So this is the, so that means this is a graph which is 4 colorable, also this is 3 colorable. Na? This graph, if this graph is G, then you can see here this G is actually 4 colorable, also this G is 5 colorable, 5 colorable, also this G is 3 colorable. Na? Why we are saying that it is a 5 colorable? Because if you have a 5-color set K, that means a set where 5 color is there. So also you can actually assign the colors in the vertices in this way that no two adjacent vertices will get the same color. That means if you have a coloring set with greater than or equal to 3 colors, then you can color your set. Is there any doubt? Is it okay? Why we are saying that this is K vertex colorable? There are 33 students. Actually, I want interactive class. From these sections, you will get obviously 2 to 3 questions. That's why it will be better if you interact in the class. This is not like a summertime class, just you on your internet and then go away from the class.
বোঝা গেছে স্যার।
Okay. And after that, now what is the chromatic number of the graph? Now we are saying the chromatic number. This chromatic number actually is the minimum number required to color a graph. That means here you can see that it is the minimum number of color required. This is the 3 colors to assign this graph, and this is called the chromatic number. And then we say that this graph is a K chromatic graph. So when we say this term, that means the K chromatic curve, chromatic graph. So that means directly that this graph G is K colorable, but not K minus 1 colorable. K minus 1 colorable. So here you can see that for this graph, this is 4 colorable and also this is 3 colorable. This is 5 colorable, also this is 4 colorable. But it is 3 colorable but not 2 colorable. Na? Not 2 colorable. That means you can color the graph by using 3 color, but you can't color the graph by using less than that. That means by 2 color or by 1 color. So then we say that this is a K chromatic graph if this graph is K colorable but not K minus 1 colorable. So here this a G is a 3 chromatic curve, is a 3 chromatic graph, and this number is denoted by, and that its chromatic number is equal to 3 here. So here the chromatic number is K, and for this graph, and it is actually denoted by chi of K, chi of actually G. This is the notation of the chromatic number of a graph. So chi of G means, that means minimum K number of color are required to color the graph successfully. And here chi of this graph G is equal to 3, where actually for our particular given problem, here chi G is equal to 3. So this is the concept of the graph coloring. So if a graph is given, you can color the graph by using different colors in this way. Okay. Now, another terms we have discussed, this is the independence set. Next, this is another term, independence set of vertices. Independent set of vertices. So independent set of vertices, actually this means if this is a graph G, and if you take a set of vertices in this way, that no two vertices are adjacent to each other. That means if we take this vertex A and if we take this vertex D in a set, that means if we create a set A where the vertices are there, vertices are, suppose A and D vertices are there. Now you can see these A and D vertices are not adjacent to each other, So we say that this set is a independent set of vertices. But if you take A and B here, this is not an independent set of vertices because they are adjacent to each other. If you take A and C, then this is a independent set of vertices because there is no edge between that A and C. Okay. So this is the concept of the independent set of vertices. That means let G be a graph. So this is the definitions. Let G be a graph and A be a subset of its vertex set, and A be a subset of its vertex set. Suppose its vertex set. Vertex set means the set consists of all the vertices of the set, and if no two vertices of A are adjacent to each other, they are adjacent to each other, and then A is called the independent, then A is called the independent set of vertices. Independent. Okay, this is independent set of vertices. That means, so just take one a graph, and if you take this graph, suppose just take one graph here, and suppose this is one graph, and suppose the vertices are denoted by A, B, C, D, E, and F. So, is there anyone who can actually state some set of independent vertices here? We are actually, we note some independent set of vertices. Independent
Sir, A and F.
set of vertices. Yes, A and F. A and F. Okay, A and F are independent set of vertices. One of this. And any other from here? Obviously B and D also in the same sense. Na? B and D. This is also independent set of vertices. Okay. B and D also. This is also independent set of vertices. B and D. Okay. And any other?
BFD.
A, B, F, D. Okay. So B, F, and D. B, F, and D. This is another. Okay. B, F, D. Any other? Here. Maybe there exist any other independent set of vertices. But these are some of the independent set of vertices where you can see these vertices are not actually adjacent to each other. Like here, this B and F are not adjacent to each other. Yes, B and F are adjacent to each other, na? Why you take B and F?
Yes, sir. Yes.
Why? So not. That means this is
Yes,
again your
sir.
D.
B and D only.
B and F, there is a connection between
Yeah.
B and F with the, so
Sir,
here
C and E হবে.
C and E. C and E, obviously C and E will be 1.
C and E, sir.
Yes, yes, yes. C and E will be 1. Okay. And any other? Because in between A and C there is a connection between, but if we omit this line from here, this AC, then you will get ACE, this structure here, or if you omit this BF line, then you will get this BDF line as your independent set of vertices. But due to this line, actually every independent set of vertices contains only two vertices in it. So like here FD is 1, here BE is 1, here BD is 1, here AF is 1. So these are some of the independent set of vertices, number 1. And if we take the same figure, but this time not with the connecting line here, and the figure will be just same as the previous. So A, B, C, D, E, and F. So like here A, B, C, D, E and F, but this time we are not connecting this A and C. So here you can see now some independent set of vertices are independent set of vertices are some of the, like the previous are already there, that means AC or the previous type AF or the previous type CE, all are there. This 333 or 2 type of set are there, but here also you will get some 3 element set like ACE. Na, you will get A, C and E. Actually these are not adjacent to each other. Any other 3 set? B, D and F, because B and F are connected, so you can take that, but you can take this A, C and E here. Any other 3 element set here present? I think no, na. If you start from A, then B, C, D are actually adjacent to them, but here also E and F are also adjacent to them. So only 3 element set, which is the independent set present here. This is the A, C and A. Is it clear? Is this?
Yes, sir.
Yes. And this number is called the independence number. Then we independence number. This is another term. What is independence number? So independence number is the cardinality of the largest independent set. So here the cardinality of this set is 2. This set have a cardinality 2. This set have a cardinality 2. This has also cardinality what 2, but this has a cardinality 3. So here the independence number is the cardinal number of the, cardinal means the number of elements, cardinal number of the largest independence set, independent set in a graph G, in a graph G. So this is called the independence number. So here if this is your graph G2 and this cardinality number is denoted by, actually it is denoted by alpha of G. So this is the notation. So in case of this G2, what is alpha of G2? Alpha of G2 is 3, because the cardinality of the largest independent set, this is the largest independent set, and here the cardinality number of element is 3. So for this graph, cardinal independence number is 3. But if you take the previous this figure and if you give it G1, then here alpha of G1 is what? 2. Na? Because the largest cardinal, the
Yes.
cardinality of the largest independent set present here, all are actually 2. So that's why here the independent number is also 2. So after that, then the another terminology, this is called the clique. This is called clique. So clique is actually, again, clique is also a set of vertices. Again, this is a set of vertices, a subset of vertex set in which every vertices are adjacent to each other, to each other. That means just the opposite concept of the independent set. That means they are dependent to each other. हर एक के बीच एक connection होगा. So this is called actually the clique. So if you just take the previous same figure, that means this is the figure. If you take this, and here this is A, capital A, B, C, D, this is E, and this is F. Now if we say that find some clique of this set, so clique of this set, so what are the cliques here? Okay. Is there any click between them?
ADB.
ADB. Why? There is no connection between ADB. So if ADB is a click, then
Hmm.
obviously there is a connection from B to D will be there, but there is no connection. If you take
So BCD.
CF.
BCD, okay, again the same thing, na BCD. If you take BCD,
So BCF.
BCF, okay, if you take BCF, there will be some, that means B to F, B to C, and C to F. Yes, you can take BCF as a connection. This is one click, B, C, and F, because B to C there is a connection, C to F there is a connection, and again B to F there is a connection. Actually, this is like a triangle. Only the edges are presenting actually in this way. But if you take the BF like this, if you take this as a BF, then it will be a triangle actually producing in your figure. So that's why BCF, it is correct. BCF is a click. Now, any other? No other three clicks here. Three element click, I think. Every other two elements produce a click here. That means AB, this is a click, or AD, this is a click, or BC is a click, or single element A, this is also click. So these are some clicks of this. So clicks means every vertices, there is a connection between every vertices, every pair of vertices of this actually subset. So here these are some clicks of the set, and then the click number is like the independence number. So click number, these are all, this is also the same thing. So click number means the cardinality of the cardinal number of the largest click, and of the graph G. So cardinality of the largest click of the graph G. That means if this is your graph G, so these are actually our graph G2. As you already mentioned here, this is the graph G2. So in this G2, the largest click is that, this is the largest click, and this is actually denoted by W of G. So here, what is the value of WG2? W of G2 is actually 3. Na? So this is called the click number, and this is the concept of click of a set. Now, if we take one problem here, so okay, before taking the problem, we also discuss the want to discuss the perfect graph concept where we left our previous class. Now we are at actually this concept. This is the perfect, like the perfect matching. So here also the perfect graph. So perfect graph means a graph G is called perfect. Perfect if for every, okay, this is very important, for every subgraph age of G, for every subgraph age of G, this W of age, that means the click number of age, is equal to the chromatic number of age. Okay, so if this hold, then we say that this graph is a perfect graph. If every subgraph age of G, if the click number is same as the chromatic number of the graph, then we say that this is a perfect graph, otherwise not. So just take one example to understood this. If you just take the previous thing, just the previous graph, suppose this is the previous graph. Again take this graph A, B, C, D. This is E and this is F, and there is a connection between this B and F. Now just take some of the subgraph here, some subgraph here. Okay, we just start with the whole graph. First we start with the whole graph, because if the whole graph have a problem, because this graph G2 is also a subgraph of itself, na, G2 is also a subgraph of itself. So first we calculate the clique number of G2 and also the chromatic number of G2. So what is the clique number of G2? We already actually calculated that this G2 have a clique number, W of G2 is equal to 3. This is the clique number. Now, what is the chromatic number of this G? Because G2 is also subset of G2. We have to check it for every subgraph, for every. And we start from the G2. Now suppose we need the chromatic number. So start coloring the graph. How to color the graph? So first just assign the number 1 color to the A. Okay, we are assigning number 1, color 1 to the A. After that, B and D are adjacent to 1. So give color 2 and color 2 at that point B and D, because B and D are not adjacent to each other. Okay. After that, C can be colored by again 1, because there is no connection between A and C. So just color this C by using the 1. And then we have E and F. E is adjacent to D but not adjacent to C. So you can color that E by using the 1. Na? And you can color the F by using 2. No, because F is adjacent to what? B. So you can't give the same color to here. So what happened if we change this, all this to 1 1? If we start the B, okay, just complete that. So this is give here 3, because you can't give here 2, because you start with the 2 here. Is it clear? Is this
Yes, sir.
coloring clear? Okay, now we just
Ji.
check,
Yes, sir.
is there any other coloring available or not? Just we check it. So again we start coloring the B with 1. यहाँ से start करेंगे. Start B with 1. After that you can give the A as 2 and C as 2. After that you can again give here 1, because 1 is not adjacent to that, and then you can put here what?
2.
And this is 1, so you can put here again what? 2 or 1, any of this. So you have to put here 3. So from anyways, from starting from here or starting from here, actually we'll see that you need actually at least 3 color to fill the graph. So here the chi of G2 is also what? Also 3. So chromatic number of this graph is also 3, and also the clique number of this graph is 3. So this is for the G2. Now take some arbitrary subgraph. Arbitrary subgraph. Suppose you take age as this graph. Age 1 is a subgraph of G, and with the vertices, so age 1 is with the vertices set C, F, E and D. Suppose you take this subgraph, CFED portions, that means these portions of the graph only, CFED. Now tell me, what is the chromatic number of this graph? What is the chromatic number? Chi of H1. This is a cycle, na? This is a cycle of even number of vertices. So its chromatic number is always
So 2.
2. And after that, what is the clique, maximum clique present here? Because there is no triangle. So maximum clique present here.
0.
No, why 0? CD is a clique.
सर क्योंकि BF के बीच में कहाँ पूछा सर?
CD is a clique, na?
Oh हाँ सर CD.
CD is a clique, D is a clique, EF is a clique. These are clique of this graph, because there is a connection between these two. So here there is no 3 element clique here, but the minimum number of cardinality here is 2. So that means your W of H1 is also 2. And similarly, obviously for any one vertices set, it will be the same. For any one vertices set, actually its clique number is actually just same as its chromatic number. But we just check another set by taking, so for this actually cycle it holds, for this cycle it also holds. And if you take this cycle, this total subset where we only take A, B, C, D, E and F, this portion. So here also if you present it by H2, here also you can see that chi of H2, the number needed, this is, you can color it by 1, first element by 1, and this element by 2, this element by 2, this element by 1, and again this element by what, 1, and this element by 2. So there also you need only 2, and if you take the W of this set, here also the same thing, the only click present here are of element 2, no 3 element click are available here. So that means here also your W of H2 is equal to 2. Now another, this triangle type set, we are now taking that B, C, F, this set, we are taking this subgraph of the graph B, and this is C, and this is F, B, C, F, and here what is the chromatic number? What is the chromatic number of that? Chi of H3. चलो इसको H3 कर देते हैं. This is the H3. What is the chromatic number of that?
So 2.
Why 2? ठीक से बोलो.
স্যার 3 হবে তো
3.
3.
You can give 2 here, because if you put 1 here and after that if you put 2 at the point C, so suppose this is 1, this is 2, so you can
F भी
put,
तो adjacent है.
obviously you have to put here 3. You can put 1 or 2 here. So that means chromatic number of H3 is 3, and what is the click number of H3? चलो H3 का click number we already know, actually this is a click,
So BCF है तो 3 होगा.
3 होगा. So that means it is also 3. So that means probably these are the subgraph, and in obviously for one element set we are only taking A, these are vertices, only vertex, so its actually chromatic number is also 1 and its click number is also the same thing. But for any other type of subgraphs, you can see that here the chromatic number is just same as the click number, so we can say that graph is a perfect graph. So our G2 is a perfect graph. We are taking another example, and this is actually important. So if you consider that graph, just consider that graph, consider the graph. Suppose this is the graph, and here, so this is A, B, this is C, this is D, this is E, and F, and this is G. Now tell me, what is the chromatic number of that graph? First we start with, suppose this graph is the G graph. Okay, this G is already here, so okay, graph is already denoted by G. So this is G graph. Now tell me, what is the chromatic number of the graph? We start with G. So what is the chromatic number of G? So start coloring the graph. A को 1 दे दो. So B is what? 2, and E is also what? 2. After that, it is not adjacent to A, so you can give it 1. But D is adjacent to 2 and also adjacent to 1, so you have to give it 3. Now F is not adjacent to B, you can give 1
স্যার
here.
বলছি বি বি তো এর সাথে কানেক্টেড, তাহলে ওটা 2 দুটো 2 কি করে হবে?
Oh হ্যাঁ, B এর সাথে connected, obviously, yes. There's a
3
connection
দিতে
between
হবে
them. There is a connection between that, so obviously put here 3 just here also, and here, so you need some another, so D is not connected, you can put 2 here, na? We can put 2 at the place of D. So now 1 is not connected with 2, 2 is 3, 3 with 2, 2 with 1, and 1 with 2. Now it is okay. And there is no connection, so 1 you can place it 1 and you can place G as 2. Now is it okay? Is this correct now? 1 2 1 2 and this is 2 3
Yes, sir.
1 3. So chromatic number is 3. Now find the clique. So what are the clique of this set? Dekho, what is the largest clique present here? There is no 4 clique available here, na? 4 element clique, but there is 3 element
AB.
clique, ABE, 3 element clique available here. So that means this ABE is a clique, ABE, and this is a 3 element clique, and no 4 element actually clique available here. So that's why it's W of G, this number is also 3. So these are same, both. Now if you take some subgraph, so this is also a subgraph. Here you can see its chromatic number is 3 and also its actually clique number is also 3, AB. Now if you take this subgraph of the graph, this as a subgraph of the graph, that means B, C, D and E. Now here you can see that if this is H1, this is H1, so then similarly chi of H1 is equal to 2, 3, and also W of H1 is equal to 3. Now if you take this as H2, this graph, then you can say that chi of H2 is what? What is chi of H2?
2.
1, 2. You can also give the 2 here and you have 1. That means chromatic number 2. And also here this H2 is, clique number is also
2.
2. And similarly, if you take this graph as suppose H3 subgraph, suppose this subgraph, if you take it, this portion of the subgraph, that means B, C, D, E, and F and G. So here also the clique number is what? 2, na? There is no 3 clique available here. So here the clique number is of this H3 is 2. So this is H3 graph. So clique number of H3 2. Now send me the actually chromatic number. What is the chromatic number of H3?
2, sir.
This is a cycle, na? Cycle of 1, 2, 3, 4, 5, 6 vertices. This is a cycle of 6 vertices and its chromatic number is always 2. So
2.
that means here also the same. And another here available is, this is A, B, C, D, E, this portion. If you take the whole portion of this, that means the additions of the CD component also here, A, B, C, D, this component A, B, C and D, and this is E. And if you take this as H4 subgraph of the graph, here also you see that what is the chromatic number? There is a 3 cycle available here. So obviously the chromatic number of H3 is always what? 3. There is a 3 cycle. So chromatic number of H4 is 3. And also this is a clique. So that means W of H4 is also 3. So that means for every possible subgraph of the graph, you can see that the number of chromatic number is actually same as equal to the clique number. So also this graph is a perfect graph. So this is a G is also perfect graph. A perfect graph. Okay. Now just take one example which is not perfect. It is also required to understand the process why it is perfect and when it is not perfect. So just take another example and where you will see that it is not a perfect. Okay, so just take this like the previous problem, but we are adding some others here. Okay, this is a 4 clique available here. You can see that this is K4, 4 clique available here, and this is 1, and add these 2 also. Then connect this, this, this is a large graph. So A, take this also, and if you add B here, this is no more a 4 clique. अब ये 4 clique नहीं है. A, B, C, D, E, and F, G, H, and I. So this is a graph. Now color the graph first. Okay. High maximum click बोल सकते हो क्या होगा? What is the maximum click here? Is there any 4 click available here? कोई भी 4 click है देखो यहाँ पर.
No, sir. यहाँ पे 3 है.
No 4 click available here, huh? Because these are, if you take A, B, C, D or something here, there is no connection between the all vertices. If you take this A, B, C, D, so here also the same case, between A and D there is no actually line. So the every click present here is either 3 or 2 or 1. So that means the maximum cardinal set is here the 3 click set. So W of this graph G is actually, this is 3, graph G. Now color the graph. So if you color the graph, then how many colors are required to color? Just start coloring the graph. चलो ऐसे start करते हैं. Put here 1. And this you have to put here 2, and you can put here 2, na? Because E is adjacent to them, but A and F are not adjacent, so we can put A and F with 2 and 2. Now you have to put something other in this E, so E is placed with 3. Okay. After that, this B is adjacent to these two vertices, so you can put 1 with B. Okay. Now C and D, you can give 3 to C, and you can't give 2 to D, na? दे सकते हो? No, because D is adjacent to F. You need another color to give here. So this is 4. After that, you can assign 3 to G and any of the others 1 to H. So this is the coloring of the graph. Here you can see you can't color the graph by using only the 3 number of colors. So that means chromatic number of this graph, chi of this graph G, this is equal to 4, and here this chi G not equal to the W of G, and it seems that this graph G is not a perfect graph. It's not a perfect graph. Is it clear? Bolo.
Yes, sir.
Yes, sir.
That's the concept of coloring and some of the topic. Just take one homework problem and find the chromatic number. Find the chromatic number of the following graph. And find whether this graph is perfect. Graph is perfect. And this is the graph. So A, B, this is C, this is D, this is E, and this is F. So just check it. What is the chromatic number of the graph? And after that, is it a perfect graph or not? Now one very important problem, and another homework problem, you can just do it now. This is just MCQ type question. Find the chromatic number of a circuit or cycle, maybe a cycle with 107 edges. Okay. Is there anyone who can say the answer? A cycle or circuit with 107 edges, how many, what is the chromatic number of it?
2.
Obvious. 2 is the answer. Because cycle or circuit 107 edges means it has 107 number of vertices, and it is odd number, so obviously chromatic number will be always 2. Now this problem is very important for exam, and this type of questions may appear, and it is also a well applications of this actually perfect graph or this coloring, very well applications, and this is the statement of the problem. Clearly understood that, and it will be very important for exam. In an examination, in an examinations, actually it is the process and which rapidly used by all the exam department, all the exam cells. So in an examination, suppose 7 subjects, 7 subjects are to be scheduled, to be scheduled, यानी कि 7 सब्जेक्ट के एग्जाम शेड्यूल करना है, and the subjects are suppose S1, S2, S3, S4, S5, S6 and subject 7. These are 7 subjects, and the following pair of subjects have common students, common students समझ सकते हो. Suppose this is S1, S2, following pair of subjects have the common student, यानी कि S1 और S2 सब्जेक्ट्स का कॉमन स्टूडेंट्स है, कुछ स्टूडेंट कॉमन है, यानी कि एक दिन में उसका एग्जाम तुम सेट नहीं कर सकते एक ही टाइम में. You can set the exam S1 and S2 at the same time, because these two subjects have some common student, and there the actually coloring concept occur, that you can set the same date to these two subjects. That means you can color with the same color with these two different vertices. That's it. That is the coloring concept. So again, then suppose S1, S3, these have some, then S1, S4. After that, suppose S1, S7, and then S2, S3, then S2, S4, and then suppose S2, S5, S2, S7, and S3, S4, S3, S6, then S3, S7, S4, S5, S4, S6, then S5, S6, and then S5, S7. After that, and at the end, S6 and S7. So this pair of subjects have common students. So that means you can't set exam on the same schedule of these two subjects. This is the problem, or constraint. So how can the question is, how can the examination be scheduled so that no students has two exam at the same date, at the same day. Okay, now you can see the complexity of the problem, that this is the problem, and you have to set the schedule the exam in this way that no students has two exam at the same day. तो अगर इसको ठीक से नहीं करोगे तो ऐसा शेड्यूल प्रोड्यूस होगा, देखोगे कि एक स्टूडेंट का एक दिन में 2 एग्जाम हो रहा है. और एक ही टाइम ओवरलैप हो जा रहा है, ये भी हो सकता है। सो दैट मीन्स एंड द क्वेश्चन इज यू हैव टू आल्सो शेड्यूल इट फॉर द मिनिमम डे, मिनिमम नंबर ऑफ डेज। इसको तुम 100 डेज से कर सकते हो कि 100 डेज एग्जाम चलेगा, तो हम अलग अलग कर देंगे, but we need to schedule it at the minimum time of interval. So this is a coloring problem. Is there any doubt that it a coloring problem, and from which angle it is a coloring problem? Is there any doubt? Okay, so now just draw the graph. Draw the graph means we will connect these vertices to produce the graph, and then we color the graph. So here we set the day as the color. Okay, this is very important, that what we set. So this subjects, we set the subjects as vertices, and the color with the day, and the day of examination, day of exam is represented by the color, different color. Now just draw the graph. Here you have total 7 number of vertices. Just give these 7 vertices here. So S1, and suppose this is S1, and put here S2, here S3, here S4, here S5, and S6 and S7. Okay. Now join the vertices. There is a S1 to S2, na? S1 to S2, join them. S1 to S3, join them. Then S1 to S4,
S4.
join them. S1 to S7, join them. S1 is over. After that, start from the S2. S2 to S3, join this. S2 to S3. S2 to S4. After that, S2 to S5. Then S2 to S7. And then S3 to S4. S3 to S4. After that, S3 to S6. S3 to S6. Then S3 to S7. S3 to S7. And after that, S4 to S5. S4 to S5. Then S4 to S6. S4 to S6. Then S5 to S6. S5 to S6. S5 to S7. S5 to S7, and then S6 to S7. So this is the graph. Now you have to color the graph, and the color actually will gives the day of examination. So from where we start? S1 से start कर दे coloring. चलो S1 से start करते हैं. So we are giving the S1 with the suppose red color or green color, whatever may be. चलो green signal से start करते हैं. This is green color. We are assigning the color here. Okay. So S1 को green color. S1 is green. After that S2 assigned है, इसके साथ S2 को green नहीं दे सकते हो, तो you have to put some other color in the S2 ना. चलो S2 को अलग color दे देते हैं. Some other color to the S2, and suppose the color is blue. Blue color at the S2. Now S3. S3 is already assigned to S1 and S2 also. So that means you have to give some other color in the S3. You can't put the blue again here. So S3 needs some red color, because if you put blue or green here, if you put green, there is a connection here. If you put blue, there is a connection with S2 here. So you have to put some other color here, obviously red. After that, for the S4, okay, for the S4, you can't give it blue, you can give it red, and also you can give it green. That means there is again problem. S4 is connected with all the S1, S2 and S3. So for the S4 you need another color. Suppose this is the yellow color we need for S4. Okay. Now, for S5, what is the case of S5? Okay. S5 is connected with S4. You can't give it yellow. S5 is connected with S2. You can't give it blue,
So
but you
green.
can give it green or red, na? Green or red, you can
Yes.
do that. So just put it green here. Okay. So just give it green. So S5 can be colored with green. After that, take the S6. S6 ग्रीन नहीं दे सकते हो, S6 में S4 वाला येलो नहीं दे सकते हो और रेड भी नहीं दे सकते हो. So only possibility is what? Blue. ना?
Blue.
Only you can set the blue here. So just give it blue. S6 को भी blue दे दो. After that S7 is remain and S7 को तो येलो दे सकते हैं ना? You can put yellow S7 because S7 is attached with green, attached with blue. So that's why, and also attached with red. So that means S7 can be filled by the yellow color. So give it yellow. Okay. So that's over. So this is the coloring of the graph, and we need 4 color to color the graph. That means the chromatic number of this is 4. Okay. So here the chromatic number of the graph G is equal to 4. We need the 4 color. That means if we say the green with day 1, suppose the green color represent day 1, if the blue color represent day 2, if the red color represent day 3, and if the yellow color represent day 4, then our exam schedule will be like this, that exam here exam day, and here the subjects. So exam day, day 1 में हम कौन सा एग्जाम दे सकते हैं? डे 1 मीन ग्रीन्स, दैट मींस S1 और S5 का एग्जाम सेट कर दे सकते हैं ना. डे 1 में S1 एंड S5, these are the green color. So day 1 S1 and S5 exam. Then day 2 can be set by what? Blue color, that means S2 and S6 exam. Day 2 can be set by S2 and S6 exam. Day 3 can be set by, day 3 means the red color, only S3 exam. And day 4, this exam may be yellow color, that means S4 and S7. S4 and S7. So that means minimum 4 days actually we need to schedule the exam in this way, and this is the schedule. Okay, this is not necessary that this is the only schedule produced, because you see that here we choose green. We have also option to choose what? Red also, na? We have also option to choose red here, but we choose green. So that's why if you choose red here, then you will get some different schedule, but chromatic number will be same, 4. Your schedule may be different, but this is one of the way by which you can set your exam, and where no students actually will have to appear more than one exam in a day.